So now let's continue still in subtopic 3.2. For this section, we are going to define the first and second ionization energies and also analyze the variations in the first ionization energy across a period and down a group. What is ionization energy? Okay, so if let's say you ada atom ataupun ion di dalam gas phase. Sekiranya your atom or ion di dalam gas phase tu, dia nak remove dia punya valence electron, dia memerlukan energy. So, the minimum energy yang diperlukan untuk buang valence electron daripada gases atom or ion, that is what we call as ionization energy. Okay, so we are going to define the first ionization energy and also the second ionization energy. So, what is the first ionization energy? So, if let's say you ada a neutral atom in gas phase, okay. So, bila this neutral atom, dia nak remove satu electron, 1 mole of electron, dia remove 1 mole of electron, dan bila dia remove 1 mole of electron, so dia remove, so dia akan form 1 mole of gaseous ion. Okay, so 1 mole of ion dalam phase gas. So kiranya kalau let's say bila this atom, gas atom, neutral gas atom, dia remove 1 mole of electron, dia akan memerlukan energy. So the minimum energy required untuk remove 1 mole of electron daripada outermost orbital in 1 mole of neutral gases atom supaya dia dapat form 1 mole of gaseous ion, cation ni ion lah kan, from its ground state. So that is what we call as the first ionization energy. Okay, so bila dia remove, kan dia akan mengeluarkan energy kan, energy, that's why kita boleh tulis sahaja dekat tepi ni enthalpy symbol here. Okay, so kalau if let's say enthalpy symbol and then ada IE adalah ionization energy. Kalau IE1, that means ionization energy yang pertama. So because dia memerlukan energy, so dia bila dia let's say dia nak remove electron, dia kena absorb energy supaya dapat remove electron daripada punya valence orbital. That's why bila dia require the energy, that's why the symbol untuk energy, ionization energy adalah positif. Sebab memang bila you nak remove electron, memang you always akan perlukan energy. Next ialah the second ionization energy. The second ionization energy, if let's say I ada X plus ni, if let's say I ambil daripada atas ni lah, dia kesinambungan lah. Okay, so if let's say X plus, I bawa turun bawah. Okay, so this is what? This is gaseous ion. Okay, kenapa gaseous ion? Sebab this ion di dalam phase gas. Okay, so bila you memerlukan energy untuk remove 1 mole of electron daripada 1 mole of singly positive ion, single kan dia punya ion, singly positive ion, untuk form 1 mole of 2 gaseous ion, 1 mole of 2 plus gaseous ion, makanya itulah second ionization energy. Still, walaupun first ionization energy ke second ionization energy, dia memang dia punya simbol dia positif. Okay, sebab kenapa positif? Because you always memerlukan energy untuk remove electron. Okay, tapi kalau let's say ionization energy yang pertama, simbol dia akan jadi IE1. Kalau ionization energy yang kedua, dia punya simbol dia adalah IE2. Okay, so kalau let's say if you want to know the magnitude of ionization energy, magnitude tu kebesaran atau kekecilan ionization energy tu, it will all depends on the strength, kekuatan of the attractive forces between the nucleus and the outermost electrons. Okay, So kalau let's say the lower the ionization energy, in this case for example, if you see this, the magnitude for the ionization energy untuk magnesium kecil daripada Mg plus yang bila untuk form Mg2 plus. Okay, so the lower ionization energy, because this ionization energy dia lower kan. Okay, the lower the IE, kiranya the lower the attractive force. Okay, attractive force between between siapa? Between nucleus and valence electron. Okay, so bila let's say the attractive force between nucleus and valence electron lemah, makanya senang ke susah nak remove electron? Mestilah senang nak remove electron. So bila ionization energy rendah, attractive forces between nucleus and valence electron pun rendah, therefore easy to remove electron, okay, from atom. So this Mg, dia senang nak remove electron untuk form a cation, okay. Macam Mg plus, dia punya ionization energy dia tinggi kan, that means susah untuk Mg plus ni untuk remove electron to form a cation Mg2 plus, okay. And the process actually is endothermic process. Okay, kenapa endothermic process? Sebab you tengok ni, dia ada positive sign untuk enthalpy. The enthalpy is in positive sign. So that's why endothermic. Kenapa endothermic? Endothermic maksudnya dia absorb energy. Okay, that is endothermic. Bila dia absorb energy, makanya dia akan memperolehi simbol positif for dia orang punya enthalpy. Okay, and then as the ionization energy decreases, the metal becomes more metallic. Okay, as it is easier for the metal to remove electron. Actually, there are three factors that will affect the magnitude of ionization energy. Kiranya kalau ionization energy tu dia besar ke kecil ke, ada tiga faktor yang mempengaruhi dia, which is the first one is atomic radius, the second one is effective nuclear charge or ZEF, and the third one is the shielding effect. Okay, tadi before this Miss ada bagi tahu, okay, one of the factors utama yang mempengaruhi the magnitude of ionization energy is all about what? It's all about the attraction between nucleus and the outermost shell. Okay, sebab kenapa? Okay, so if let's say the attraction between nucleus and the outermost shell is stronger, so bila attraction dia kuat, makanya saiz dia kecil, betul tak? Okay, so tak kisahlah, tapi if let's say the attraction between nucleus and the outermost shell kuat, makanya susah ke senang nak remove electron? Mestilah susah nak remove electron. So bila susah nak remove electron, you perlukan banyak energy tak untuk remove the electron? Of course you perlukan banyak energy. So bila you perlukan banyak energy, makanya apa berlaku pada ionization energy? Ionization energy pun akan increase. But if the attraction between nucleus and the outermost shell is weaker, jadi saiz dia makin lama makin besar. Okay, tapi we don't care about the size. But if the attraction between the nucleus and the outermost shell, if this is nucleus, this is outermost shell, if let's say dia punya weaker, okay, makanya elektron tu senang dia nak apa? Dia nak remove. So bila senang nak remove electron, you perlukan banyak energy tak untuk remove the electron? You will not need much energy to remove the electron. So bila you tak perlukan banyak energy, apa yang berlaku pada ionization energy? Ionization energy pun akan jadi rendah. Okay, so pokok pangkalnya apa-apa you kena relatekan dengan the attraction between nucleus and the outermost shell. So the first one is atomic radius. Okay, kalau atomic radius, the atom saiz dia besar. Bila saiz dia besar, sebab apa saiz dia besar? Sebab dia kurang attraction towards nucleus and the outermost shell. Okay, so bila attraction between nucleus and the outermost shell berkurang, makanya senang nak remove electron. Okay, bila senang nak remove electron, therefore the ionization energy untuk atom yang bersaiz besar is low. Okay, Next ialah effective nuclear charge. Kalau let's say effective nuclear charge tinggi, bermaksud the attraction forces between the nucleus and the outermost electrons or the valence electrons kuat. Okay, so bila dia punya attraction between nucleus and electrons kuat, this will cause the ionization energy to increase. Sebab kenapa ionization dia increase? Sebab bila attraction between nucleus dengan outermost electrons tu kuat, susah kan nak remove electron. So bila susah nak remove electron, you will need more energy, hence the ionization energy increase. And the last one is the shielding effect. Okay, shielding effect of the electrons in the inner, dia akan cause the nucleus shielding effect. Kalau let's say shielding effect main peranan, that means the attraction between the nucleus and the outermost shell ataupun outermost electron or the valence electron akan jadi kurang. Okay, kalau shielding effect main peranan, attraction between nucleus and the valence electron akan jadi kurang. So bila jadi kurang, apa berlaku? Makanya senang nak remove the electron. So bila senang nak remove electron, makanya ionization energy for those yang ada large shielding effect akan jadi decrease, akan jadi rendah. Okay, next Miss akan bincang the trend of ionization energy moving across a period in the periodic table of elements and going down the group in the periodic table of elements. Okay, so let us discuss first the variation of ionization energy when moving across a period in the periodic table of elements. So, bila kamu move across a period in the periodic table of elements, the element daripada metal jadilah ke non-metal kan? So, daripada metal dia akan jadi less metallic or non-metallic or more non-metallic. Okay, so bila you move across the period, you need to remember pizas. So what is pizas? Bila move across the period, your proton number will increase. Bila proton number increase, apa akan berlaku pada effective nuclear charge? Effective nuclear charge akan increase. Bila effective nuclear charge increase, bermaksud the size of your atom will be decrease. Okay? And how about the attraction? Okay, so the attraction between the nucleus and the valence electron will become stronger. Sebab kenapa? Sebab now the valence electrons will be closer to the nucleus. Okay, so bila valence electrons are closer to the nucleus, sebabkan attraction mereka kuat, jadinya susah nak remove the electron daripada atom. Susah nak remove electron. Okay, so bila susah nak remove electron, makanya you will need more energy untuk remove the valence electron. Okay, outermost electron ni adalah valence electron. So bila you memerlukan more energy to remove the valence electron, therefore the ionization energy will be increase. Tadi Miss dah bincangkan, generally kalau across the period, the proton number increase. So bila proton number increase, effective nuclear charge increase. Bila effective nuclear charge increase, therefore the attraction between nucleus and the valence shell akan increase. So you memerlukan more energy to remove the electron. So bila you memerlukan more energy to remove the electron, makanya the ionization energy will be increased. So actually, generally kalau you move across the period, the ionization will be increased from left to right. But except adalah anomalous cases yang Miss dah highlightkan color kuning ni ya. So kita akan bincang about it later. Okay, tadi kita dah bincang kalau across the period, semakin bertambah proton number, semakin bertambah juga ionization energy. So kalau across the period 2 going from Li to Ne, if let's say you build the ionization energy trend in a graph, you'll see that generally memang dia akan menaik. Okay, macam period 3 juga. Generally daripada Na going across the period from Na to argon, so dia punya ionization energy memang bertambah. Okay, tapi ada anomalous cases. Ni macam tercoek. Ni pun tercoek. Macam dekat period 3. Ada tercoek dekat MgAl dan juga PNS. So kenapa? Sebab tercoek tadi itulah dekat graf tu, itulah yang kita namakan sebagai anomalous cases. Okay, so there are anomalous cases in the period 2 and period 3 in the periodic table of elements. Okay, tapi in general, kalau you move across the period, memang the ionization energy sepatutnya sekatalah menaik. Okay, tapi there will be an exception in the period 2 and period 3, which in period 2 there will be two anomalous cases, BEB and also N dan juga O. Okay, kalau in period 3 there are two cases as well, which is between MG and AL and also P and S. So if let's say you tak ingat macam mana nak hafal the anomalous cases of the ionization energy yang berlaku di period 2, then you boleh hafal macam ni. Contohnya, babe, no. So kiranya you tahulah. Kalau in period 2, babe, no tu ialah is between BE and also B. And O ialah between N and also oxygen. Okay. So kalau if let's say you tak hafal the anomalous cases in period 2, in period 3 of the ionization energy. Okay, so you boleh maybe you can say that multis ke, multis ialah MGAL, PS PS lah, PS. Sebentar dia tak tahu lah macam mana you nak hafal, tapi you do you, okay. So let us discuss more about the anomalous cases for the ionization energy in period 2 and period 3. Tapi in this case, Miss nak serangkan dulu in period 2. Okay, kalau period 2, there are two anomalous cases in period 2 that sound like babe, no. Okay, so the first case ialah between BE and B. The second case is between N and also O. Okay, so sekarang ni Miss nak bincang dahulu the anomalous cases in period 2 between BE and also B. BE adalah beryllium, B adalah boron. BE terletak pada grup kedua, boron terletak pada grup 13. And if you look at the graph here, you can see that the ionization energy of BE is higher than B. Why? Kenapa? Okay, so you just tengok saja this key point here. A completely filled orbital is more stable than partially filled orbital. Okay, sebab kenapa? Sebab if let's say you tulis electronic configuration untuk BE dan B dan mereka mempunyai masing-masing punya atomic orbital, so you can look at BE, 2s orbital, the valence. Okay, you look at the sebab ionization energy is all about the valence shell. Okay, valence shell orbital ataupun valence electron. Okay, sebab kenapa ionization energy kan adalah energy yang diperlukan untuk remove electron dekat valence orbital, ataupun minimum energy yang diperlukan untuk remove the valence electron, right? So that's why we focusing on the valence orbital. Okay, so if you look at boron, the valence orbital terletak pada 2s dengan 2p, tapi kat belakang sekali kat 2p lah, sebab ionization energy dia mesti nak remove electron daripada 2p dahulu. Okay, so if you look at atom BE ni, beryllium ni, if you look at the 2s here, dekat atomic orbital of 2s here, you can see that in beryllium it has a completely filled 2s orbital. Okay, while boron dia ada partially filled 2p orbital. If you look at 2p orbital in boron here, you can see that dia bukanlah half filled, tapi bukan juga fully filled, jadinya dia partially filled. And if you look at statement di bawah ni, a completely filled orbital is more stable than partially filled orbital. Okay, so let's go through dekat dia punya penerangan. Okay, in beryllium, bila kamu nak remove electron from a fully filled 2s orbital, dia akan membuatkan atom tu less stable. So bila let's say dia buatkan atom tu less stable, makanya susah untuk kamu remove the valence electron. So bila kamu susah nak remove the valence electron, makanya you perlukan energy untuk more energy untuk you remove the valence electrons in 2s. Sebab kenapa 2s orbital in beryllium ni dia complete, okay? So jadinya bila let's say more energy is needed to remove the valence electron in 2s, makanya the ZEF will be higher, effective nuclear charge will be higher. Bila effective nuclear charge is higher, therefore the attraction, ni yang penting ni, this point yang penting, the attraction between nucleus and the valence electron is stronger. Ni adalah point yang sangat penting. Sebab bila you nak tahu you punya ionization energy rendah ke tinggi ke, you akan depends on the attraction between nucleus and the valence electron. So in case BE, dia punya attraction between nucleus and valence electron in 2s orbital is stronger. Therefore, the ionization energy of BE is higher than B. Okay, next let's move on to B, boron. Boron, dia punya 2p adalah partially orbital. Okay, so let's say, if let's say you remove this electron, one electron daripada 2p, kan bila you nak buat ionization energy kan you akan remove electron kan. So bila you remove electron, makanya apa yang berlaku pada 2s, 2s akan jadi complete field orbital. Dia akan, so that's why bila you nak remove this partially electron dekat 2p, it is more favorable sebab dia akan menjadikan atom tu more stable. Okay, sebab dia nak get rid of this. Okay, so bila dia dah get rid of this, kiranya dia nak sangat get rid of this one electron in 2p, makanya it is easy to remove the valence electron. Sebab bila you getting rid of this, you buang this one electron dekat 2p, makanya 2s ni akan jadi lagi stable. Okay, sebab itulah apa? Senang nak remove valence electron dekat partially filled orbital. Okay, so bila senang nak remove electron, you akan pair dengan exponential, therefore the shielding effect will be increased. Bila shielding effect increase, apa berlaku pada attraction between nucleus and the valence electron? Akan jadi lemah. So you perlukan less energy untuk remove the outermost electron. Therefore ionization energy of B is lower than BE. Okay, tadi Miss dah bincang the anomalous cases in period 2 between BE and B. Okay, so now let's move to N and O pula. Okay, so N terletak di group 15, manakala oxygen terletak di group 16 in the periodic table of elements. So if you look at this graph, you can see ada tercoret kat sini. You can see that the ionization energy of nitrogen is more than oxygen. Why? Okay, so you tengok dulu, this is why. It is because the half-filled orbital is more stable than partially filled orbital. Okay, sebab kenapa? Sebab if let's say you tengok dekat nitrogen, if you build dia punya atomic orbital, you can see here dekat 2p ni mempunyai a half-filled orbital. Half-filled kan, sebab 2p sepatutnya 6, tapi 6 bagi 2, 3. Ada 3 saja. So, nitrogen mempunyai half-filled p orbital. Manakala oksigen 2p berapa? 2p 4. This is actually a partially filled orbital. It's not even half, it's not even complete. Okay, so let's look at the explanation. Okay, explanation dia lebih kurang sama je ya. Okay, sebabkan nitrogen ni dia half-filled, dia ada half-filled punya orbital kan, dia punya valence orbital, makanya susah nak remove the valence electron. So bila susah nak remove the valence electron, more energy yang diperlukan untuk remove the valence electron. So bila you perlukan more energy untuk remove the valence electron, makanya the attraction between nucleus and the valence electron bertambah kuat. So bila attraction dia bertambah kuat, sebab itulah more energy diperlukan kan. Therefore ionization energy of nitrogen is higher than oxygen. Okay, kalau you tengok dekat oxygen pula, okay, kalau let's say you remove one electron dekat valence electron of this oxygen kan, you remove satu lah, one of them. So bila you remove one of them, akan jadi partially filled. That means kita memang favor, kita memang nak buang this one electron supaya dia jadi atom ni jadi more stable. So bila let's say bila remove this one electron akan menyebabkan oxygen atom ni jadi lagi stable and happy, macam itulah. Jadinya actually easy to remove the valence electron in oxygen of a partially filled orbital. Therefore, the shielding effect increase the attraction between the nucleus and 2p electron is weak. Bila attraction dia weaker, therefore you memerlukan kurang energy untuk remove the electron. Sebab itulah ionization energy of oxygen is lower than nitrogen. Okay, so basically kalau let's say between BE and B is because reason dia kenapa, because BE is dia ada fully filled orbital. Okay, fully filled orbital dekat dia punya valence orbital. Manakala kalau N dan O pula, okay, N is more dia punya ionization energy dia more than O. Sebab kenapa? Sebab N dia ada half filled orbital dekat valence orbital dia. Okay. Okay, next Miss nak discuss pula mengenai anomalous cases of ionization energy in period 3. Kalau period 3 ada dua juga anomalous cases. If you remember just now, multis between MgAl and also phosphorus and sulfur. So untuk ni Miss discuss dahulu between Mg and Al. So if you look at the graph here, generally memang sepatutnya across the period sepatutnya straight sahaja line, sebab semakin bertambah proton number semakin bertambah ionization energy, tapi ada anomalous kat sini. Okay, ada kepelikan kat sini sebab ada tercoet. Sebab apa? Because a completely filled orbital is more stable than partially filled orbital. Why? You know that magnesium, dia punya ionization energy is more than Al. Is because if you look at the atomic orbital for the magnesium here, you can see that the valence electron terduduk pada 3s, orbital 3s kan. So if you look at 3s here, it's a completely filled 3s orbital. Okay, manakala if you look at the Al, okay, Al dia punya valence orbital dia berada pada sini kan, tapi yang paling terkeluar sekali ialah pada 3p. 3p ada satu saja elektron. So is actually Al ada partially filled 3p orbital. Okay, so kalau ikutkan discussion yang before this, kenapa ionization energy tu more? Okay, if you know that Mg ada completely filled orbital, maka susah nak remove electron dekat valence electron of the Mg atom. So bila susah nak remove electron, makanya you perlukan banyak energy to remove this electron. So bila you perlukan banyak energy, apa berlaku pada attraction? Sebabkan attraction between the nucleus and the valence electron is stronger, therefore ionization energy untuk Mg will be higher than Al. Okay, untuk Al pula, since dia ada partially filled, makanya if you kick out this electron, you buang this electron, 3s akan jadi completely filled orbital. So bila 3s jadi completely filled orbital, makanya senanglah untuk kamu remove this outermost electron. Senang kamu nak remove this valence electron. Sebab apa? Sebab dia akan menjadikan atom Al tu lagi stable. So bila senang nak remove electron, makanya apa berlaku pada attraction between nucleus? Bila senang nak remove electron, makanya the attraction between nucleus and the electron and the valence electron will be weaker. So bila attraction dia lemah, senang nak remove electron, makanya you tak adalah perlukan banyak energy untuk remove the electron. You perlukan sikit saja energy untuk remove the electron. Therefore, ionization energy of Al will be lower than magnesium. Sebab pokok pangkalnya a completely filled orbital. You tengok orbital mana pada valence electron, okay, is more stable than the partially filled orbital. Okay, tadi Miss dah bincang pasal anomalous cases in period 3 yang berlaku pada Mg dan juga Al. Now we are going forward for phosphorus and sulfur. So if you look at here, ada kepelikan dekat trend between phosphorus and sulfur sebab ada tercuang 8 kat situ kan. Because the ionization energy of phosphorus is more than sulfur. Why? Because this, you ingat ni, half filled orbital is more stable than partially filled orbital. Okay, so if you look at electronic configuration of you tengok dekat dia punya valence orbital which berada pada 3p. Okay, 3p in phosphorus adalah half filled orbital. Okay, manakala dekat sulfur if you look at dia punya valence orbital, okay, you look at here ada 3p4, bukanlah half, you tengok kat sini, it's not even half, it's not even a fully filled orbital, it is a partially filled orbital. Okay, since you know that half filled orbital is more stable than partially filled orbital, therefore susah kamu nak remove electrons dekat 3p orbital in phosphorus. Sebab kenapa? Sebab dah stable, half filled orbital ni is more stable. Okay, so bila susah, kenapa susah nak remove electrons? Sebab the attraction between nucleus and the valence electrons in 3p is stronger. Therefore you need more energy, kita perlukan banyak energy untuk remove the electrons, the valence electron in phosphorus. Sebab itulah ionization energy of phosphorus is more than sulfur. Okay, manakala sulfur, because it's a partially 3p orbital, if you look at here, if you remove satu saja elektron di sini, if you remove satu elektron di 3p ni, makanya 3p akan jadi dia punya valence orbital dia akan jadi half filled kan, makanya akan membuatkan atom sulfur tu jadi lebih stable. Makanya you lagi suka, sulfur ni lagi suka untuk remove this one electron. So bila dia senang nak remove the valence electron in 3p orbital, makanya sebab kenapa senang nak remove? Because the attraction between the nucleus pun weaker. Therefore you perlukan sikit sahaja energy. Bila senang nak remove electron, senang lagi sikit lah, you kaitkan ni. Bila senang nak remove electron, sikit je energi yang kamu perlukan untuk remove the electron. Bila sikit saja energi untuk remove the electron, makanya ionization energy akan jadi rendah. Okay. So basically, if you look at dekat period kedua, ada anomalies between BE and B, N dan O. Period 3 ada anomalies between MG and AL and also P and S. Okay, so kalau BE BE ni kenapa dia higher than B and also kenapa MG ni higher than AL? Because diorang punya valence orbital is completely filled. Okay, completely filled. Dia penuh. And then manakala kenapa nitrogen dia higher ionization energy daripada O dan kenapa phosphorus higher than ionization energy of sulfur? Because why? Because valence orbital untuk N dan juga P adalah half filled. Okay, so macam mana you nak tahu? You kena buat SPDF notation and also kena buat orbital diagram, baru you boleh nampak. Okay, and from there you know that completely filled orbital and also half filled orbital is more stable than a partially filled orbital. Okay, sebab kan diorang more stable, because they are more stable, makanya susah nak remove electron. So bila susah nak remove electron, you perlukan banyak energy untuk remove electron. Bila you perlukan banyak energy nak remove electron, makanya ionization energy pun akan jadi increase. Next, I am going to discuss about the variation in the first ionization energy when going down the group in the periodic table of elements. When going down the group, ingatlah ansatz, ya. Apakah itu ansatz? Okay, bila you going down the group, you akan add electrons to the next energy level, to the next energy levels. Okay, so if you look at here, if this is group 1, okay, if going down the group, elektron tu akan bertambah pada next successive energy levels. Therefore, the number of shell akan bertambah. Bila number of shell bertambah, apa berlaku pada shielding effect? Bertambah. Apa berlaku pada attraction between nucleus and the outermost shell? Berkurang, and therefore the size of the atom will be larger. Okay, when going down the group, tadi Miss suruh kamu ingat point apa? Ingatlah point and size. Okay, tetapi kalau kita tengah bercakap mengenai ionization energy, kita kena fokus kepada main point yang menyebabkan besar ataupun kecil value of your ionization energy, which is dia akan berkait dengan point A. A ni adalah apa? A adalah point attraction, which is when the force of attraction between nucleus and the valence electrons becomes weaker as going down the group. Okay, bila dia punya force attraction jadi weaker, makanya senang ke susah kamu nak remove the electron? Senang nak remove the electron. Bila senang nak remove electron from each atom, makanya kamu hanya perlukan sikit saja energy untuk remove the first electron. Okay, because when we are talking about the first ionization energy, we are talking about the removal, pembuangan of the first electron of the atom. Okay, therefore bila kamu perlukan sikit saja energy untuk remove the first electron, the ionization energy will be decreases. So the general trend in the first ionization energy, kalau let's say across the periodic table of elements, the first ionization energy will be increases, except in period 2. Kalau period 2, the anomaly will be between BE dan juga B. Kalau period 3, between MG dan juga AL. Kalau let's say and lagi satu ialah between nitrogen and oxygen in period 2, and also phosphorus and sulfur in period 3. Okay, tapi generally the first ionization energy across the periodic table of elements should be increases. Okay, should be increases. Sebab kenapa? Sebab across the periodic table of element, the size of the atom will be decrease. Kenapa size dia decrease? Sebab the effective nuclear charge increase. So bila effective nuclear charge increase, apa akan berlaku pada attraction? So therefore the attraction between nucleus and the valence electron akan jadi stronger. So bila attraction dia stronger, you susah ke senang nak remove electron? You susah nak remove electron, susah nak remove first electron. So bila susah nak remove first electron dekat valence electron, makanya apa yang akan berlaku pada first ionization energy? The first ionization energy should be generally increases. Okay, so if let's say if you are going down the group, the atomic radius will be increases. Okay, kalau you going down the group, the size of the atom akan membesar. Sebab kenapa? Sebab shielding effect increase. Okay, bila shielding effect increase, therefore you akan tahu kalau going down the group, the attraction between nucleus and the valence electron akan jadi weaker, kan? Weaker. So bila dia punya attraction weaker, maka susah ke senang nak remove electron? Senang nak remove electron. Okay, bila senang nak remove the first electron daripada valence electron, makanya the ionization energy will be decreases. So basically ionization energy dia akan bergantung kepada attraction between nucleus and the valence electron. And secondly, susah ke senang nak remove electron? Berdasarkan kesenangan ataupun kesusahan nak remove first electron at the valence electron. Okay.